All right, guys, we're going to learn about inscribed angles. So let's kind of talk about what an inscribed angle is. So our notes say an inscribed angle is an angle with its vertex on the circle with two sides that are chords. So if you remember, a chord is a segment that goes from one end of the circle to another edge of the circle. So basically, we can say BC is a chord if I could draw straight lines. Another chord we have here is AB. Okay, so these two lines are chords. So an inscribed angle is an angle with its vertex on the circle. So we've looked at angles that, let me just draw one that's kind of overlapping. We've looked at angles that connect to the radius. Okay, these are called central angles, right? Where their vertex is right there at the center of the circle. But for inscribed angles, the vertex or the corner, where those two segments meet, that is called an inscribed angle because it's on the edge of the circle. Okay, so this right here, that angle is an inscribed angle. Okay, it says an intercepted arc is the arc that lies between the endpoints. So if this is our inscribed angle, the endpoints that are not the vertex, right, are these 2 points, okay, where the angle goes out to. This arc right here, right, where these two angles are, that curve right there, that is called the intercepted arc. And our notes also say that the degree of an inscribed angle is equal to half the measure of the intercepted angle. So if you remember correctly, when we talked about central angles, so like this one, for example, so let's call this theta, okay, that's a Greek letter, which is usually used to describe the measure of some angle. Okay, so if the measure of this angle is theta, okay, just like a variable, we don't know what it is, we're just going to call it theta. If that's theta, then the measure of this arc right here is also theta, okay? But notice that the measurement of this central angle is bigger than the measurement of this inscribed angle, okay? Even though they go out to the same endpoints, this one's bigger than that one. Well, they have a very special relationship, right? Our notes say that this angle B or angle ABC is actually half the measure of this arc. So if this arc is theta, then this is half of theta, okay? Or if we call the angle X, if you're more comfortable with alphabetical letter variables, then you can call it X, and this angle B would be half of X. So just with your notes, okay, angle ABC is an inscribed angle, okay? So that is our inscribed angle. Inscribed angle. Okay, our other term was intercepted arc. So arc AC, so this arc right there is our intercepted arc. Lastly, the degree of the inscribed angle is equal to half the measure of the arc. So if angle AC is equal to X or theta, okay, if the measure of that is X or theta, okay, then the degree of angle ABC, so the measure of angle ABC is going to equal half of that, okay? So this is just looking at our notes, and we're just kind of describing what they actually say, what they actually mean, okay? There's more information on our notes. Not only do we have inscribed angles and intercepted arcs, and we see a pattern between the degree of the inscribed angle and the intercepted arc, but we also have something else in our notes. Our notes also say that if we have an inscribed angle that intercepts a diameter, that means that the two endpoints of the angle are at the diameter. So I'm going to go ahead and draw a diameter. Remember, diameter goes through the center of the circle and goes all the way across from one end to the other. So this line right here, I'm going to call it BC. is the diameter. So if my intercepted angle intercepts a diameter, which means the endpoints are where the diameter lands, okay, are the two endpoints of the diameter. So let's just say my intercepted angle A is right there, and the endpoints are where the diameter is. Then the measurement of this angle is 90 degrees, okay? Then angle BAC is a 90-degree angle because its endpoints are the same endpoints as the diameter, okay? That is always the case for an intercepted angle that intercepts the diameter. Okay, we also have one more thing in our notes. It says that it is something called overlapping arcs, okay? It says that if we have two inscribed angles that intercept the same arc, then the angles are congruent. So let's draw one angle first, one intercepted angle. So I'm going to have this angle that goes out to this endpoint and goes out to this. This is my inscribed angle. Okay, notice the arc is all of this, right? That whole edge. Not only does this angle, let's call this A, B, C, okay? It says that if this angle, this arc, overlaps with the arc of another inscribed angle, then those two angles are congruent. So that means I need to draw another, let me draw it a different color so we can see the two different angles. We have another inscribed angle, let's call this D, okay? But it has the same arc as this inscribed angle. So I'm gonna draw, that means the endpoints are exactly the same. It shares this arc AC, okay? They have the same arc. They're overlapping arcs, okay? That means in our notes, it says that this angle is congruent to that angle if their arcs are overlapping, okay? So if this is 30 degrees, this is 30 degrees. If this is 50 degrees, then that's 50 degrees because their two arcs are overlapping. In other words, they have the same two endpoints and the distance right here is the same, or the measure of that arc is the same. So these two inscribed angles are congruent to one another. So we're going to use this information that is given to us to solve some problems. All right, guys, let's say we have a circle. This circle has inscribed angles RST. Okay, here's an inscribed angle. Okay, and another inscribed angle is RUT, RUT. So there's another inscribed angle. Notice that both of these angles end up in the same endpoints and they share this arc right here. Okay, so if we look at that like that individually, I know seeing all the lines can be a little confusing, but if we look at RST individually, we notice that these two are the endpoints. So this is the inscribed arc. If we look at RUT on its own, okay, it also has those endpoints, so that it means it also has that arc. They share this inscribed arc. It's overlapping. They have overlapping arcs. So what that tells me is that these two angles, these inscribed angles, will be congruent. They will be the same measurement. What I need to do is find the measurement of those angles. What do we know about these angles? Well, I know that these two angles are congruent, so whatever they're going to end up measuring, they're going to be the same. So I know this is twice as big as this angle, which means if they're congruent, that's also twice as big as that angle. So what I'm going to do is I'm going to take 82 and divide it in half, okay? And you should get 41 degrees. Okay, if this is half the size of this, then this has to be, I divide it by 2 and it has to be 41 degrees. And if these two are congruent, well, this one also has to be 41 degrees. So hopefully this is pretty easy. Both of those angles are 41 degrees. This is using my knowledge of overlapping arcs combined with the relationship that I know that inscribed angles and intercepted arcs have. All right, guys, so the next part of our notes talks about inscribed quadrilaterals. Inscribed quadrilaterals are some sort of four-sided figure, right? inside of a circle where all the vertexes or the corners of that figure are on the edge of the circle. Okay, so let's say I have this circle with this inscribed quadrilateral, and let's call the points A, B, C, D. Okay, and P is my center. I just always mark my center because that's part of what circles have. They all have a center. So our notes say if a quadrilateral is inscribed in a circle, if it's inside of the circle where the corners are on the edges, then its opposite angles are supplementary. So let's take angle D. The opposite angle is the angle that's not next to D. So I see A is next to D, C is next to D. So the opposite angle is B. There are on opposite sides of the quadrilateral. That means they are supplementary. And remember, complementary means they add up to 90 degrees. Supplementary are angles that when added, they add up to 180 degrees. So I know that the measure of angle D plus the measure of angle B is equal to 180 degrees because they are supplementary. Also, A and C are opposite of one another. So angle A is opposite of angle C. So I also know, because they're opposite angles, that they are supplementary. So that means that the measure of angle A plus the measure of angle C is equal to 180 degrees. That's just what supplementary means. They add up to 180 degrees. So let's go ahead and use what we know about inscribed quadrilaterals to solve some of our homework problems or some examples of homework problems. So let's say we have a circle, okay, with, let's say this is M, J, let's put K right there, and L right there, and let's connect all of these points with segments. Okay, let's say my center is point N, doesn't really matter. And this problem gives me some measurements. So it tells me that angle M is 45 degrees. Okay, it also tells me that angle L is 92 degrees. Okay, so I want to find the other two these other angles. I want to find the measure of angle J and angle K. What quality do inscribed quadrilaterals have is that the opposite angles add up to 180. So I'm going to look at angle L because that's one of the angles that I know. I'm going to look for the opposite angle of angle L. That's angle J. Since there are opposite angles, if I add them together, they will equal 180 because they are supplementary. So I know that angle L plus, or the measure of angle L plus the measure of angle J is equal to 180. So I'm going to go ahead and plug what I know in. I know that angle L is 92 degrees. So 92 plus the measure of angle J is equal to 180. So I want to solve for the measure of angle J. So I'm just going to subtract 92 to both sides. And I know that the measure of angle J is equal to 180 minus 92, which is 88 degrees. So now I figured out that this angle is 88 degrees. Okay, now I'm going to find my other angle, the second angle that I want to kind of figure out because I don't have the measurement of it, angle K. So again, opposite to angle K is angle M, and I know angle M, so I can use that information to find angle K. So I know that the measure of angle M plus the measure of angle K is equal to 180 degrees because they are supplementary angles. So I'm going to plug in 45 degrees because I know that the measure of angle M is 45 degrees plus, instead of writing out the measure of angle K, if that's confusing for you to look at, you can just put X, right? It's the same thing as just solving for a variable. So I'm going to subtract 45 degrees to both sides. And I get the measure, I'm just going to write it next to it, the measure of angle K is equal to 135 degrees. Okay, so now I've found both of my missing angles, and that's all I really need to do to find the measurements of this inscribed quadrilateral.